Hello, everyone, and thank you for the opportunity to participate in the second round of this competition, and welcome to our presentation. So our team created a manuscript titled Predicting the Falsehood of a Tweet Concerning COVID-19 Using Its Location, Socioeconomic Data, and Tweet Sentiment. So before we get into things, I want to take a moment to introduce our team. Next slide, please.
Hi, my name is Danish. I'm studying at the University of Waterloo, and I study nanotechnology engineering.
Hi, my name is Sabina Henry. I study biology at the University of Ottawa.
Hi, my name is Kaho Wang. I study nanotechnology engineering at the University of Waterloo.
Okay. Next slide. Okay, and now we can get into the meat of our manuscript, starting with the problem we're trying to address. Next slide, please. As many of you know, misinformation regarding COVID-19 is everywhere, especially on social media platforms such as Twitter. It can often be difficult to tell a false tweet from a true tweet without doing an independent fact check. So we looked into how to predict whether a tweet would contain true or false information based on 3 factors. Next slide. The 3 factors we addressed in our manuscript were the socioeconomic status of a Twitter user, the location of the user, and the sentiment behind the tweet. We expect all 3 of these factors to play roles in predicting the validity of a tweet independently, as well as through the interaction between them. Next slide. Just before we jump into our analysis, I want to say some words about how we gathered and transformed our data into easier to work with numbers. So we started out by gathering our socioeconomic data from the US Census website. And we also started out with a data set of tweets, which contained tweets and their Twitter IDs, which were labeled as true or false in regards to COVID-19 information. So we took Twitter IDs from those tweets and we ran them through a hydrator software in order to isolate the location and the content of the tweets, which we use later on in our analysis. So from the contents of the tweets, we used the Vader sentiment software to determine the sentiment behind them. And then we used the one-hot encoding method to convert categorical data, such as location by state and region, to a format which could be fed through a logistic regression model. Next slide.
Now let's take a look at the analysis and the results section. In this paper, we have developed some classification models using logistic regression. This roadmap shows the workflow that we use in order to develop and evaluate the models. After the data have been processed and handled, we evaluate the non-categorical variables independence that are to be used in our models. We create a visual heat map which shows the correlation between each variable and selected the variables with least correlation. For the categorical variables, they were encoded using one-hot encoding method. In our tweet dataset, only 3.7% of the tweets are labeled as fake. This can result in imbalanced classification models which have poor performance on the minorities class. To address the issue, we implement the synthetic minority oversampling technique, also known as SMART for short, which duplicates data from minority dataset. Once the dataset had been processed and corrected, we randomly divided the dataset into training and testing set following a 7:3 ratio. Using the training dataset, we created logistic regression models using a Python library named sklearn. We have created different models using different variables, which are region, state, socioeconomic indicators, sentiment, and a mix. Here the region and state refers to the location of which the tweets were originated. There are 5 regions and 52 states in the US, and they are hence categorical variable. The mix refers to model made with socioeconomic indicators and sentiment. Using the testing dataset, we determined a few key logistic regression scores, such as precision, recall, and F1 score to evaluate our models. As mentioned, a heat map showing the correlation between non-categorical variable was generated to help choosing the useful indicator to use. The heat map was generated using Seaborn Python library with +1 representing positive dependence, -1 representing negative dependence, and 0 representing independence. First, the sentiment polarity shows low to none correlations with other categorical variable. The correlation PMAP show a significant overlap among the education variables, with percentage completed advanced degree being strongly correlated to percentage completed bachelor. Other than that, the intersection of the household income and poverty has a correlation of -0.58, which validates the heat map, as increased household income should lead to a decreased poverty rate. The decision for picking the useful socioeconomic indicator landed on household income and percentage completed high school, as their intersection show the least correlation with a value of 0.094. Below shows the logistic regression model scores of different models for both tweet and reply classification. The best performing model in terms of accuracy was the mixed approach, which includes the selected socioeconomic indicators and sentiment polarity. This model has an accuracy of 56.3 to 60.6%. The mixed model was followed by the sentiment model with an accuracy of 54.9 to 59.3%, supporting the decision to add socioeconomic data to the mix. The highest record score for predicting face tweet belongs to the sentiment model, with the score being 63.5 to 72.3%. And lastly, the poorest performing model was the region model, which has an accuracy of 50.8 to 52.2%.
And now I'm going to go through some of the analysis we did to kind of draw useful conclusions from our data, and then talk about next steps and the key findings. Next slide. So we wanted to kind of interpret what location and sentiment meant in our model and what kind of impact they had. So on the left side, we can see our state model being represented in a map of the US. So basically any states that had coefficients above 0.5 are labeled blue, and below negative 0.5 are labeled red. Basically what this means is a positive coefficient in the model indicated that a tweet coming from that state is more likely to be false, and a negative coefficient meant that is more likely to be true. So we can see between the tweets and the replies to tweets, both maps, there's some similar states that give both, are more likely to give both false and untrue tweets. Yeah. And on the right side, we see our model coefficients for the mixed model, and looking at the sentiment polarity, we can see that there's almost 3 times greater weight of sentiment polarity in the tweets versus the replies to tweets, indicating that sentiment of the original tweets themselves is more powerful indicator than the replies to tweets. Next slide. So if we were to improve our model, we basically want to increase the resolution we have for the location. So our original data set was around 200,000. We had to cut that down to 40,000 after we filtered for states. It would be really interesting to see what kind of results we get if we used city or county locations and census data from those locations. For improving the sentiment scores, we could actually aggregate sentiment scores from multiple different sentiment analyzers that have different sort of rules for analyzing sentiment of text. So right now we use Vader, or we could use BlackBerry Twitter or blob text sentiment analyzers. Next slide. In conclusion, we found that mixing socioeconomic data and sentiment data generated the most accurate model. We found that models based on the original tweets rather than replies to tweets performed better and were more accurate at identifying falsehoods. And we looked at a kind of interesting location based analysis in logistic regression. Next slide. So now we've come to the end of our presentation. Thank you so much for listening. If you have any questions, feel free to email us at the emails down below. Thank you.